My very first controls project worked exactly the way I designed it. The project was an inline barcode verification system that could be installed into our existing lines for a customer. The project was simple enough that it was given to myself as a brand new engineer. For the first round of systems, we shipped 3 of them. They were installed, the customers were very happy, and nothing broke. As the years went on, we deployed more and more of these systems. New features were added, until eventually the code was so complex and confusing that there were only a few people in the company that actually knew how to make changes to it. And one of those people was me. Welcome to From the Bucket, where controls design meets reality. I'm your host, Keely Smith. In this podcast, we will explore industrial control systems as they actually exist in the field, not just how they looked in CAD or how they were supposed to work on paper, but how they operated in a production environment, how operators and maintenance were able to manage the systems after they were installed, and lessons that I've learned throughout my career as a controls engineer. And the first story I want to tell is about a system I built very early in my career that worked perfectly, or so I thought, then slowly became a problem that I had to live with for many years afterwards. Before we truly get into the story, I think it's important to take a second and talk about who I am and why I care about controls. Before I ever touched a PLC, I was just a kid taking things apart. Computers, electronics, realistically anything with wires. If it had screws, I wanted to know what was on the inside. I was always more interested in how things worked than how they were supposed to be used. That curiosity pulled me towards programming and electronics, but for a long time, all the work I did lived entirely inside of a computer. I think the part with computer programming that didn't quite hit right was nothing actually physically happened in the world a lot of the times. You write some code, you give it an input, and there's an output that appears on that screen. So again, nothing's actually really happening outside of what's happening inside your computer. And honestly, that just never really quite clicked for me. It wasn't until later in my time in college that I was attending a career fair that we had going on. And as I'm wandering around all these big flashy booths, I walked past this booth that was honestly pretty terrible compared to the rest of the booths, where all these other companies had a whole pile of people that were running around trying to talk to you, bring you in, get you interested in the booth. This particular booth just had a single guy sitting there, where all these other booths had all sorts of flashy things to grab your attention and really pull you in. This guy just had a single TV, no banners, no giveaways. I remember the first time that I walked by, I looked at him and just had this feeling of like, why are you here, man? Like, I just didn't quite understand it because compared to everybody else, his booth just was not anywhere close to what kind of the expectation was at this career fair. But I noticed the TV and I noticed what he was playing on the TV, and what it was a industrial robot working on a palletizing application. To be entirely fair, at the time I absolutely had no idea that it was a palletizing application. And to be extra fair, I at the time didn't even know what I was really looking at. I just knew that something about it was special and kind of stuck with me. I kept walking. I did the whole career fair loop. I talked to other companies. I got more information on what other companies were doing. But that guy just stuck with me. A few hours later, I found myself walking by that same booth again. It was the same guy, same TV, still sitting there, just watching people walk by, smiling at him. And I remember thinking, I don't know why, but I felt like I really needed to talk to this guy. So here I am again, staring at this screen with this process that I just didn't understand. I didn't really fully comprehend what it was, but again, just something was interesting about it. So I started talking to the guy, and that's when I learned that, hey, this is a industrial robotic application. And, it's one of those things you talk to somebody and they hear the word robot. And, we all get this idea of, oh, robots. Gotcha. Okay. I understand that. And you start thinking, is this something that I could do? Like this guy has a company that they're programming robots. I mean, that's pretty cool because you got to remember at this point everything that I've done was sitting inside of a computer. So here's this guy showing something totally different. He's showing these real world inputs, these sensors, the cameras, encoders, and he's showing when a program is running inside of this robot, something physically is happening. There's motors moving, there's conveyors moving, there's robots doing things. And that was really the first time I saw a career path where I could do hardware, software together and actually make something happen in the real world. And once I saw it, it was hard to care about anything else. I remember talking with this guy for what seemed like hours at the time. He told me he was there. He was the department manager for a controls engineering group, and he was looking for interns. A couple of weeks later, I accepted a intern role at his company, and he became my first boss in automation. The company ended up being an absolutely incredible small business. They had, I believe it was around 20 employees when I first started working there. There were a few really neat things that were happening at this time in my life. One was that I started working in the field of automation, and it was with a small company. So the cool thing that, I found that I loved about the small company was that, yeah, I was hired as a controls engineering intern, but I was actually able to be a part of a lot more than just doing the controls engineering. I was able to be part of the mechanical install, actually seeing the designs and doing a lot of that stuff that, when you get into like the bigger companies, it's a lot more segmented. Like just getting started in automation just felt like I was absolutely drinking from a fire hose. There was just so many different avenues that you could pursue. There's so many different bits and pieces of it that all kind of work together. One of the avenues that absolutely just immediately drew me into it was machine vision because it's such a different way of thinking. When you can physically see an object with your eyes, you get all this data and you don't really realize that you're getting all this data until you try to emulate that in an industrial environment with a sensor that just doesn't have that ability to, pull all these different data points without you telling it what data points are actually important. It wasn't long after that I was handed my first real controls project. Not only was it my first vision project, but it was actually also my very first exposure to PLC ladder logic. And it's a project that taught me the difference between clever design and good design. So let's get into the project. So the project was a barcode verification system. The idea was pretty straightforward on the surface. We had cartons moving down a line that we needed to verify the barcode was present and readable. On the hardware side, we decided to go with 6 cameras positioned around the conveyor, basically in a hexagon, with the idea being that no matter what side of the carton the barcode was on, we would theoretically have 2 cameras that would capture it. From the very beginning, the idea was that there was going to be a lot of expandability built into this system. So while the original system had 6 cameras, there was always an intention that the system would continue to grow as our customers' needs changed. Coming into this as a brand new engineer, with a software engineering kind of background and mindset to this, the first thing that I thought is, well, we should go and abstract basically everything, because that way, as the system grew, we had already done abstraction to make everything kind of expandable, or so that was the idea. I took the concept as far as I possibly could. So if I had a camera that was going to be on the leading right edge of the system, well, I couldn't call that a leading edge right-handed camera, because what if we had two leading edge cameras, or we stacked a camera on top of each other? So I took the idea and I said, you know what? Why don't I just call this camera 1? And then I call the next one camera 2. That way I can write the code for however many cameras. If you have 12 cameras on this, you would have cameras 1 through 12. So, okay, cool. I've got a plan now. Well, we got to document this, so let's take the mechanical drawings of this system, and then I'll just label the cameras. So now I have created a document where I say, hey, camera 1 is this camera on this system. So I've created that abstraction, and I've made this infinitely expandable. And all you need is this document to tell you this is what camera 1 actually is. So far, so good. This hasn't really created too much of confusion, right? It's not super great naming convention, but there's documentation behind it. But wait, I have inputs and outputs. I have things like photo eyes that I need to be able to move around. So I can't just call this input 1, because what if it's input 3 on the next system? So, okay, we have to look at a different way of doing this. So maybe I don't call this input 1. Maybe I just call this bit 1 or Boolean 1. All right. So now I know that, hey, every single system, the trigger for triggering the cameras is going to be Boolean 1. Awesome. I've got this map now, so I can continue with this map. So let's say I've got different integers. I've got different data types that I could move them around from system to system. Well, let's just call everything generic. That way, no matter what we do, it should all match up, right? So at this point, you're probably starting to see where the problem is, right? Because now I have multiple documents outside of the PLC that are required to understand the logic. So there's nothing really in the PLC anymore that's telling you what actually means anything. So, and again, you got to preface this with, I'm a brand new controls engineer doing brand new things. So if you're thinking, well, did you at least put anything in a data type? No, absolutely not. I had no idea what a data type was. So there was nothing in a data type. There's no add-on instructions. There's no really anything in this logic that, being later in my career, I understand, like, hey, all of these things are kind of exactly what you're trying to do with this code, and it's already built into the systems. So ultimately, after continuing down this road of my madness, the system actually ran. Like, there's nothing inherently wrong with the approach here that would make it so that the system doesn't work. And that's where I think you can kind of get into the weeds, right? Because everybody has a different way of approaching every problem in controls. I have both heard and made the joke throughout my career that if you were to gather 10 controls engineers in a room and ask them to solve a problem, you would be given 10 different solutions, and every one of those controls engineers would think that the other 9 engineers are idiots. With this particular project, I thought that I was doing something really great. Because I really didn't have much oversight with this project, we deployed it. So we deployed the first few systems, everything went great. We deployed a few more systems, it went great. The overall product line that we had developed was going really well. Things were actually working really well. We were catching all of the problems that the customers were trying to catch. So the product as a whole looked like a really successful product. We really didn't start seeing issues until we went to do upgrades or expand on the idea. So I can think of like one of the really big ones that we did was we decided that we wanted to start being able to capture the barcodes on top of basically a jar. And that was a huge change because up until this point, it really didn't matter how many different cameras we had, they were all looking at the exact same barcode. So it really didn't matter. So when you go and you add a barcode on a lid, it's typically is not it's not a UPC barcode because the barcodes that we're looking at on the sides of containers are the UPC barcode. So it's actually what you're scanning when you're at like the grocery store. The barcode on top of the container is typically more of like an internal QR code. So if you were to scan it, it really doesn't mean anything. So in order to actually process that barcode, we had to start tearing apart the logic to actually figure out where we were doing the comparisons, where we were doing all of the logic behind whether a container was a pass and fail container. The other thing that happened here was when you have two barcodes on a system, you end up having to have almost a bit of a database to say this barcode belongs to this lid, which again creates huge changes inside of a code base. Now, had I actually programmed this system correctly, it would have been as simple as modifying a data type and saying, hey, we're going to be comparing these two data types instead of these two data types, right? Eventually, we get the code working. So, yay, success. We have added this new feature into the code. It's working. Again, customers are happy. Everything's good. The problem is that on the back end, we had to really try and cobble something together to do this new logic. So now a code base that was already really confusing and hard to follow just became way harder to follow, and it just got way worse than it was before. Again, technically, the system is still running, so we're not really dumping that much money into a software redesign. More time goes by. We continue to deploy these systems. We continue to add more features to it, make more changes to it, make improvements to it. We're adding more and more to these systems. And it was already a bad code base to begin with. So the more we added to it, the just more this thing became kind of this monster that really nobody wanted to support or could support. I think at this point, we probably had around 10 to 15 of these systems deployed. So even if we wanted to stop everything, do a complete code rewrite, and try and fix the mistakes that were made at the very beginning, it was too late. You can't undeploy 15 systems. So at this point, you're probably thinking, all right, cool. So he's laid this out. He's really talked through what the project was, what the product was, and all the mistakes with it. So cool. So how did he fix it? So that's the fun part of this story is it's not actually fixed. There's really no clean ending here. There's no success moment where we rewrote the whole system. We never went and fixed all of these new features properly. We just kept brute forcing it. The system is still deployed today. To my knowledge, that code is probably still out there running. It's one of those things that, again, being later in my career, I've seen a lot of different code from a lot of different companies, And I kind of questioned, like, how did this code actually make it through this company? But I look at this particular project and I know that this code is still out there. It's still running these systems. And it was written by an intern that was realistically learning how to program while doing this project. This is just one of those things that I think it happens in everybody's career, right? Where, you make bad decisions, you make bad design choices early on in your career, and a lot of times they kind of disappear, right? So if you make a decision that has a negative consequence in a lot of different industries, that could eventually go away, right? But with controls, we have this ability to create systems that could be there for 10, 20, 30 years. And it's just kind of a weird thing to think about that, one of my very first things that I ever did in this field is like this absolute terrible spaghetti monster of code. Like it's just probably the worst thing that I've ever written in my entire career. And knowing that that code could exist and could continue to run for the next 20 to 30 years is just crazy. So there's really no happy ending to this project. I think that the biggest thing that we can do as controls engineers is look at the things that we did that were really bad, the code that we wrote that was just a really terrible code, the different systems that we've designed that have just been really terrible systems, and we can reflect on them, right? So by the time the issues really started showing up with this code, I really wasn't a brand new engineer anymore. I had started seeing different ways of structuring control systems. I started seeing that, there are ways to take the ideas that you learn in software design and apply them in ways that actually made sense in industrial automation. Because industrial automation it's different. I think that people like to think that programming is programming is programming, but it's really not. It's different. There's nuance to every type of programming out there. And this is just an example of where you take a concept from one thing, so like a high level programming language, and you try to apply that in an industrial setting, and it doesn't work the same. I think that there's really important times in everybody's career where you kind of have that aha moment. And like I said, the issues with this system really didn't start to appear until I was later in my career. And by the time that the issues started to appear, I had that better way of framing my thinking. So when I saw the issues, it's like, okay, well, this is how I would fix this now. I would try and take these different things, and I wouldn't try to make everything so generic. I would try and create objects, and with those objects, then expand it out. Taking kind of that understanding of the software engineering ideas and actually playing within kind of this industrial automation sandbox. So there you have it. That's my very first project as a controls engineer. I think this is one of my favorite kind of cautionary stories from early in my career that, most control systems don't really fail in these big dramatic ways. They kind of fail slowly. They become harder to understand, harder to change, harder to support. You start getting into issues where the companies that you deploy your systems to, your maintenance staff don't understand the system. They can't really support the system. Your operators aren't able to actually run the machinery, run the lines, run, whatever it is that you've deployed. I think this story is one of those really great stories where, if you've ever stood in front of a panel or you've ever opened up some code and wondered why something technically works, but nobody really understands it anymore, you're not alone. These sort of situations happen all the time in this field. And I think that that's one of the things that just makes this field so incredibly fun and unique. We look at the things that we do as controls engineers. We look at, the decisions that we make at the time that felt like really good decisions. We look at the trade-offs that, you know, not everybody gets to see, and we get to experience these systems that we are a part of, we do things with, we deploy, and we end up having to live with it. Off the top of my head, I really can't think of that many other industries where a decision that you make today could potentially still follow you for the next 20 to 30 years. In future episodes, I want to continue to talk about those moments. I want to continue to talk about these systems that we have to live with. This is From the Bucket, where controls design meets reality.